Welcome to qnawire.
For this section and this problem in particular, we're going to be using the divergence theorem, which states the following formula essentially right here. And what we're going to want to do is compute the volume integral. So we know that the divergence of f is going to be partial derivative of p with respect to x, partial derivative of q with respect to y, partial derivative of r with respect to z. So what we end up getting as the divergent of f is going to be equal to the square root of 3 minus x squared. So with that in mind, we can take this portion right here and replace it with this. Then we want to define x, y, and z, their bounds. This is probably the most challenging part. We know that dv will be dx, or dz, dy, dx. Our z bounds are going to be from 0 to 2 minus x to the fourth minus y to the fourth. Our y bound will be from -1 to 1, and our x bound will be from -1 to 1 as well. So we already have the answer, but we want to solve this maybe a little further to understand what's expected. So when we do the first integral, we'll end up just getting this times 2 minus x to the fourth minus y to the fourth. This dy dx. As we see, we're getting the same value as a result. Then this is going to be equal to, solving further, we'll end up getting 321 times the square root of 2, and we're allowed to use a calculating tool for this. So our answer is going to be that, plus 81 over 20 arc sine, or sine inverse, of 1 over the square root of. And we see we get a fairly similar value. It won't be exact, but we can go with either this, or we can stick with this value right here. But regardless, this would be what we end up getting out of it. And if it's done properly, another way we could write it would be this. It's the same thing, but we see that regardless of how you write it, it'll either be that or 1 over the square root of 3.